To begin this presentation, we will first look at an important stepping stone of trigonometric history by viewing one of the building blocks that led to the modern trigonometric functions and ideas. The chord function was an extremely important part of the modern development of the sine, cosine, and tangent functions. It was discovered by both Hipparchus of Nicaea from ancient Greece and Ptolemy of Roman Egypt. The first known trigonometric table was a table of the chord function, calculated for angles incrementing at 7.5 degrees. The theta of a chord function can only lie within 0 and pi. All this means is that a chord is a straight line connecting any 2 points on any curve. A chord is just any line segment with endpoints that lie on a circular arc. The longest chord of any circle is its diameter, a line segment on a circular arc that passes through the circle's center point. The chord function gives the length of the chord outlined by the terminating and initial side of two lines of an angle theta apart, or in simpler words, the chord function determines the length of the line created when you connect the two endpoints of the angle in, for example, the unit circle. To better understand the history of the concepts included in the AP Precalculus curriculum, I will do a short review of each concept before talking about its history. Because this is a historical-based project, I'll only go over what is necessary to understand the concept so that I don't bloat the presentation. The radian is a unit of angle measurement based on the length of a circle's radius around a circumference. Using the circumference formula, c is equal to 2 pi r, we can infer that 2 pi radians are equal to 360 degrees, as it envelops the entire circumference. One of the first documented uses of circle lengths being used as units were in some of al-Kashi's works from the late 1300s to early 1400s, who was an Iranian mathematician. He used diameter parts as units, each part being 1/60th of a modern radian. The more modern concept of a radian was developed and began to be understood by Roger Coates, an English mathematician, in his book Harmonia Mensurarum, published as a collection of his mathematical writings in 1722. His most profound contribution to the idea of the radian was expressed through an editorial comment, where he described the measure of the radian in terms of the degrees used for a measurement at the time. Quoting his writing directly, he says, "Now this number is equal to 180 degrees as the radius of a circle to the semicircumference, as this is 1 to pi." What this means more clearly is that he understood a method of measuring angles by using units of radius length arcs along the circumference. He knew that the number of these new units that would be equivalent to 180 degrees would be equal to the amount of times you can fit a circle's radius into half of its circumference. He went even further, saying that this number is pi, which makes sense because the relationship between a radius and a semicircumference is the same as the relationship between the diameter and the circumference, the traditional ratio resulting in pi. This is near explicitly the modern-day definition of the radian, even showing that pi radians are equal to 180 degrees. The 6 essential trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. Each function corresponds to ratios of the sides of a triangle in correspondence to a certain angle, where sine is derived from the ratio of the opposite side to the hypotenuse, cosine from the ratio of the adjacent side to the hypotenuse, and tangent from the opposite to the adjacent. The reciprocal trigonometric functions correspond to the reciprocal of those ratios, so cosecant would be the ratio of the hypotenuse to the opposite side, and etc. The development of the modern sine and cosine functions can be traced back to the Jia and Koti-Jia functions in 4th to 5th century Indian mathematics. They were first seen in the Surya Siddhanta, a treatise or a comprehensive written work in Indian astronomy. It contained rules to calculate the orbits, motions, and locations of different celestial objects. The Jia and Koti-Jia are actually functions of circle arcs, not angles. This is important to remember, as even when the 6 main trigonometric functions developed, such as sine or cosine, they represented lengths of circle arcs, and over time became used as functions of angles instead. Both the words sine and cosine have been traced back to the 2 Sanskrit words. The Jia function, in simple terms, gives the length of a circle's half-chord. The formal definition uses a section of a circle arc, with endpoints A and B. If you draw a line from the center of the circle, O, to the bottom end of the arc, shown as line OA, and draw a line perpendicular to OA from the top of the arc, shown as BA, the Jia of arc AB is equal to the length of BM, and the Koti-Jia is equal to the length of OM. Most of the trigonometry of this time took place using circle arcs, and thus the unit circle quietly evolved alongside it. This relationship between ratios of sides and triangles and circle arcs gave way for the eventual development of the sine function by name. The 3 main inverse trigonometric functions are arcsine, arccosine, and arctangent. They can be used to find unknown angles, as instead of finding the value of the function from an input, it finds the input of the function from its value. Because they are inverse functions, instead of periodically repeating x values, they repeat y values, so the function's domain has to be restricted in order for it to remain valid. The definition of the inverse sine function was also outlined in the Siddhanta, where tables of it were found alongside with tables of the sine function and verse sine function, an order function where verse sine is equal to 1 minus sine. The modern notation of the inverse trigonometric functions were first used by John Herschel, an English mathematician born in 1792 who also invented the blueprint. The polar coordinate system takes on an r-theta form, where points are plotted rotationally around the origin by a measure of theta radians and have a distance away from the circle of r, or radius, units. They allow for the graphing of polar functions, and they are used for astronomical and navigational purposes both in history and today. Hipparchus's chord table also had references to polar coordinates establishing the positions of stars in astronomical sections of the text. Many of the ideas and developments within angle measures at the time in Greece were developed through his ideas. Archimedes, another mathematician in ancient Greece, wrote a treatise called On Spirals in around 225 BCE. It contained the idea of the Archimedean spiral, a function whose radius depends on the angle, but this idea did not extend to a coordinate system. In the 8th century onwards, astronomers began to use trigonometry to find the direction and distance of Mecca, or the Islamic holy site, from any point on Earth by converting its longitude and latitude and using spherical trigonometry with a polar coordinate system where the distances could be modeled. From the 1600s onward, polar coordinates were used to solve problems involving Archimedean spirals and calculating the length of parabolic arcs, but the term polar coordinates was coined by Gregorio Fontana, an Italian mathematician born in 1735.